Hello everyone and welcome to my channel. Today we're going to talk about principal component analysis in R. Before we continue, if you are just joining us and you have not subscribed to my channel, kindly do so. This would help me to be able to produce much more helpful videos in future. Also, hit the notification bell to get instant notification once new video is uploaded. Feel free to drop your comment in the comment section and also give a thumbs up if you find this video helpful. What is principal component analysis? So principal component analysis is a dimensionality reduction technique used to identify patterns in high dimensional data by transforming it into a smaller set of uncorrelated variables called principal components. So what is the theorem behind principal component analysis? 1. For calculating the covariance metrics to measure relationships between variables. That is the first. The second, computing eigenvalues and eigenvectors to find the principal component. Third, transforming the original data into a new coordinate system where the axes are the principal component. So why use a principal component analysis? 1. For reducing dimensionality of datasets. 2. To eliminate multicollinearity between features. 3. To simplify data visualization in 2D or 3D. And lastly, to improve computational efficiency and model performance. So when to use a principal component analysis? So we use a principal component analysis when our data has a large number of features. 2. When the features are highly correlated. 3. When you need to reduce noise or extract key patterns. And lastly, when you want to visualize data in few dimensions. Now, the use of features here. Features are same thing as variables, but not all variables are features. So the variables that we can call features are those variables that are included for the purpose of the analysis. Okay, so scenario for making use of a principal component analysis. So let's say we have this scenario. So we are trying to manage a portfolio of 100 stocks. So the problem here is that there is a high dimensional data with correlated stock returns. So what is the solution? We make use of principal component analysis to identify key factors driving stock return. Example, market trends. So what is the benefit we are going to get for making use of principal component analysis? The benefit is reduce dimensionality, also improve risk management, and to simplify the portfolio optimization. Alright, so now what are the steps to perform principal component analysis in R? So the first, we load our data set and pre-process, e.g. handling of missing values and standardization. Then we make use of the precom function to perform the principal component analysis. Then we visualize to understand the explained variance using a Scree plot. Then we transform the data into the reduced dimension for analysis. So additional tips. Now, before you perform a principal component analysis, always standardize the data before applying the principal component analysis. Use a Scree plot to decide the number of components to return. Combine principal component analysis with domain knowledge for meaningful insight. And be cautious. Principal component analysis can reduce interpretability as features are transformed. So be cautious. So quickly, let's go to R to see how we can do this and the codes required. Alright, so here in R, we are having this various code loaded already. If you have not installed these following packages, ggplot, dplyr, tidyverse, factor extract, you kindly do so and load them in your R. So first, we load the data in our R Studio using the read.csv, and this is the part where my data is saved. So you can change this to represent the path your data is saved. Then after which you control enter so that it will be loaded in your R Studio. So under my environment, I'm having 250 observations, all right, and 101 variables. So here we are looking at the stock returns for 100 the portfolio for 100 stocks for the period of 250 days. So now I am going to remove the date column because the principal component analysis requires only numeric data. So I would use the code stock underscore return brackets comma -1 comma. So I'm omitting the first column. So I will do so, and the new information here is stored in our environment. So you see for the first stock return we're having variables as 101 because the column for date was included. So after removing the first column, I'm having 100 variables. So the column for date has been discarded. So now I will standardize the data. Before performing the principal component analysis. So I will perform the principal component analysis and give the summary. So under the summary, we can see that we're having principal component 1 down to principal component 100, and for each of the principal components we're having their standard deviation, the proportion of variance, cumulative proportion as well. So we can visualize the proportion of variance in using a Scree plot to be able to decide which of the percentage of the principal component we are going to be keeping and the percentage we would be discarding. So let's perform the plot. Alright, so let's wait for it to load. Alright, so this is the Scree plot. The Scree plot here, we are having the x-axis. So for the x-axis, here we're having a principal component. Alright, so each bar represents a principal component ranked in descending order based on the variance they explained. So for example, the principal component here, 1, explains the most variance, followed by the principal component 2. So for the y-axis, we're having variance explained. So this represents the height of each bar and shows the proportion of total variance explained by the principal component. For instance, the first few components here typically explain significant proportion for variance here, so while the last ones contribute least. So what are the insights of this particular plot? So we can observe that the plot starts with tall bars for principal components 1, 2, etc., indicating that the first few principal components explain the majority of the variance. The height diminishes rapidly, showing diminishing return for adding more components. Now, we are going to look for the elbow or point where the explained variance stops decreasing significantly. So now, the reason for doing this is because this particular point indicates the optimal number of components to retain, balancing dimensionality reduction and information reduction. In this case, the elbow might be around 10 to 15 components, depending on the specific goal. So now, for the interpretation of dimensionality reduction, we can retain only the first few components that explain significant proportion of the variance, e.g. 80 to 90%, and discard the rest, simplifying your data sets without losing much information. Okay, so basically that is it. So why use the Scree plots? So just like I said earlier, this visualization helps in deciding how many components to keep so that we can reduce noise in the data, improve model efficiency by reducing computational complexity, and also avoid overfitting by removing less significant components. Alright, so that is the essence of this plot. So having seen the plot, we go to the next code. We retain components that explains 90% of the variance. So to retain components that explain 90% of the variance, we use the code here. So we Ctrl enter this, Ctrl All right, so we control enter this, so you can see under your console that number of components explaining 90% variance are 71. So now let us transform the data to a reduced dimension. So we're using the principal component underscore results and saving it under reduce underscore data. So now let us print the first few rows of the reduced data using the head. All right, the head open parenthesis reduced underscore data close parenthesis. And so after doing this, we can see the first few rows of our reduced dimension. Now let us save this data into our on our PC using the write.csv. So this part here, you would change it to the part you want to save your CSV file in your PC. So Ctrl Enter. All right, so you see that the reduced data set saved successfully. So when I go to my desktop, I will find it there. So this is the data here. So you can open it to cross-check your information whether it is complete or not. All right, so while it opens, if you have not subscribed to my channel, kindly do so and hit the notification bell to get instant notification once new video been uploaded, and kindly give a thumbs up if you find this video helpful. So here is our information. We are having our data here, reduced data here, and they are 71. Okay, so now if you want to perform further analysis, you can now use the reduced data set for that. So that is the main purpose of making use of the principal component analysis.